Hi, it's Valentine from Simplistic again. So in this problem, we're going to basically try to predict the equilibrium constant for this reaction out here. And we're given the equilibrium constants for two other reactions. So whenever you see problems like this, where you're given two different equilibrium constants and you're supposed to predict the third, they basically want you to combine these two equilibrium constants in such a way so that you get an output for this equilibrium constant. And the key to that combination is to look at these two reactions that are given to you and try to figure out how can you combine these reactions or manipulate them to get this reaction. And based on what you do out here to get this, that's what will show up as you manipulate the equilibrium constants. So let's take a look at this. So just by inspection, you can see that in the output reaction, so the first reaction out here, you have carbon dioxide and hydrogen on the left-hand side, or the reactant side. It turns out in this, the second reaction, you actually have those same two reactants on the right-hand side. And so that means your first thing needs to be is you need to flip this reaction around. So you need to make the reactants the products and the products the reactants. So that's the first thing with what we're going to do out here. So when I flip that around, I get CO2 gas plus H2, and that gives me CO plus H2O. Okay, so when you flip a reaction around, then the equilibrium constant becomes a reciprocal of itself. So this one is going to become 1 over K2. That's the equilibrium constant, 1 over K2. All right, so we're not going to do any calculation yet because we're going to do the calculation all in the last step. So right now we have this flipped around. Now, if you take a look at the third equation out here, if you add this equation to this, turns out you actually will get this. Let's see how that happens. So I'm just going to write this reaction below this. So I'm going to write CO plus 2H2 gives me CH3OH. And that's going to be K3 for this one. No change in the equilibrium constant, simply because it didn't change this reaction. Now, some of you might be wondering, how did I know to do that? Well, the reality is, once I flipped the second equation, and made this, I realized that I had an H2 out here, which could be added to 2H2, which gives me 3H2, which is the same as what I have out there. And then I also noticed that there was no carbon monoxide in the first equation. And it turns out when I flip this around and I get this out here, then carbon monoxide ends up on opposite sides, which means they get canceled. So that should be an indication that, okay, we're on the right track. So I'm just going to go ahead and add these two together. And when I add them together, the carbon monoxide gets canceled. And what I have left is CO2 plus 3H2, which gives us CH3OH plus H2O. Okay, so when you add reactions together, then the equilibrium constants get multiplied. Okay, so therefore K1, because that's the equilibrium constant for the first reaction, K1 is going to be equal to 1 over K2 times K3. Now all I have to do is take the values of K2 and K3 given to us and plug them in and solve. So when I do that, I get 1 over K2 is 1.0 times 10 to the 5 times K3 is 1.4 times 10 to the 7. And if I solve that, let's go ahead and write that down here. If I solve that, I get 1.4 times 10 to the power 2. And there you have it. That is the equilibrium constant for this reaction. I hope that made sense. Thank you for watching.